Hi everybody. In this video lecture, we are going to see network flows. So what is network flows? In real time, we are seeing many applications. For example, consider internet. So here, the routers or the devices which send you, which gives you the net connection or net facility are considered to be vertex, and the wire connection or cable connection or a link between them is called the edges. So you can see same way telephone, cell phone, highways, rails, electric paths, water, etc. So water, if you are considering, you will be having many lakes or many sources of waters, they will be considered to be vertex. The pipes which is connecting those sources will be considered to be the edges. So in real time, you can map many scenarios to be a graph. So now in this lecture, we are going to see network flow. So what is network flow? You will be having many vertices connected with many pipes. So your many pipes or many edges. Your aim is you have to find the maximum flow. If you are choosing whatever be the path, you can choose what will be the maximum flow. That is called as network flow problem. So here you will be having a directed graph G, which is having vertices V and edges E. So every edge will be having a capacity C of E. This capacity will be always greater than 0. Then you will be having two special nodes. That is the source node called as S and the sink node called as T. So this is a graph scenario. Here what is your problem? Your problem is you have to find the total amount of the flow which is maximum. So from S to T, from source to sink, what is the maximum flow? Maximum total amount of flow, that is what you are going to find. Always you have to keep two constraints in mind. The first constraint is flow on the edge should not exceed the capacity, because if the capacity is having 5 units, means you cannot pass more than 5 units in that. So always the edge flow should not exceed the capacity. Then except the source and sink, if you are taking any vertex, the incoming flow and the outgoing flow should be equal. If you are seeing a problem, it will be more clear. So before going into the problem, you have to know certain terminologies. So here, this is a graph. This will be always a directed graph. So you will be having a source node and a sink node. Source will be denoted by S and sink will be denoted by T. So here all the edges will be having some weight. This weight is considered to be the capacity. Consider this is a pipe. So all edges are pipe. The maximum capacity will be represented here. Now if you are taking particular path and if you are trying to send or flow something in that, that is called as flow. So you will be denoting by flow slash capacity. So in the numerator you will be having flow and the denominator you will be having capacity. Once this is 0, you cannot use that edge. So this is the basic terminology. Actually we are having a certain formula. Let us see directly a problem. So we are going to apply Flukerson algorithm. So we will be seeing the working and then we will be seeing the algorithm. So I will tell you the algorithm. So this is a given graph. For this graph, what is the maximum flow? This is what you are going to find. So here I am having a source node, here I am having a sink node. So what are the 3 possible ways here? Many ways can be possible. Here 3 ways are possible. This is one way to reach S to A to T. This is one way to reach T. The other way is S to B, B to A to T. The other way is S to B, B to T. So 3 ways you are having. So initially I am taking this path. So in this path, I want to reach source to destination, sink. What is the maximum flow I can have? Here in this edge, you can imagine edge as pipe. So in this edge or pipe, maximum you can pass or flow only 6 units. Here you are having the capacity is 7. But if you are putting 7, this pipe will not be working because the maximum is 6. So for this entire path, 6 is the maximum. So now you are making the total flow is equal to 6. So here you are subtracting that. So the numerator, the flow will be now 0 because you have given the 6 to total flow. Here in this pipe you have given 6 to total flow. The remaining flow available is 1. So out of 7 capacity, 1 is available. Now this path I have chosen. Now second, I can choose any path. It is my wish. Whatever path you choose, finally the total flow will be the same answer you will be getting. So second, I am having two options. I can go by this way or I can go by this way. So I am going to choose this path. So now if I am choosing this path, here in this pipe I am having 10, in this pipe I am having 4. So the maximum I can send, though the capacity is 10 here, here the capacity is 4. So only the minimal value I can take for flow. So it will be 6 plus 4. I am subtracting 4 here and here. So 6 by 10 and 0 by 4. So now my total flow is 6 plus 4. Clear? Now the last path remaining is here to here, here. So here I can pass 6, here I can pass 8, here I can pass 1. So the minimal value is 1. So I can pass only 1. So I am adding 1 to the total flow plus 1. So everywhere I am subtracting 1. So this will become 5, this will become 7 and this will become 0. So now the maximum flow is 6 plus 4 plus 1. So the maximum flow is 11. So to be more clear, we can see one more problem in the next lecture series. Stay tuned. Thank you.